Okay, before we start getting into the instructional aspect of this, let's just quickly go over what exactly an infrared photograph is. Usually, we are taking pictures in the visible light range, and when you look on the electromagnetic spectrum, visible light is actually only a very small portion of the entire electromagnetic spectrum. Our cameras are actually capable of taking photographs in the UV light range, which is below the visible light spectrum that you see on this graph here, but it's also capable of taking near infrared photographs. And you can see that's between 700 nanometers and about 900 nanometers. The reason why we can't see the infrared frequencies is first because our eyes aren't capable of seeing near infrared light, and our camera sensors have a filter that blocks out the near infrared frequencies from hitting the sensor. Because normal people don't want to take infrared pictures, they want to take regular color pictures that we see with our eyes. But if we remove that infrared blocking filter that is in front of our camera sensor, we can capture light in the near infrared range. Now, not all cameras block out near infrared light completely. In fact, a lot of them still let in just a tiny bit of IR light. And if you happen to have a camera that's like that, we can actually take an infrared picture pretty easily. Alright, so enough of the technical what is an IR photo. Let's go into why you would want to take one in the first place. They're really cool and artistic. They darken blue skies and eliminates haze. So in a normal photo, usually you'll see that the sky is usually kind of sometimes too bright and blown out. Well, an infrared picture will darken the blue skies totally, sometimes almost making them completely black. But in turn, it leaves the individual clouds very bright. So it's not like it's darkening the entire sky. It's darkening the blue sky and leaving the white clouds very bright. And the vegetation as well, like trees, leaves, grass, things like that, that's all going to be bright as well. So you get this very interesting dynamic range, basically, in a landscape photo. And when you're taking pictures of people, it has the potential to make their skin very silky smooth, sometimes too smooth to where it looks kind of ghostly. Um, but sometimes this is kind of a desired effect. It reduces acne, so you hardly can see the acne anymore, and skin blemishes like that. Now, if you don't want to look like an Oompa Loompa with blue hair and red skin, you can simply make the photo black and white. So I bet now you're wondering, can I take an infrared photograph with my camera? Well, the answer is yes. There are two different methods that we can go about doing this. The first method is the best method. It's where either you or you can send in your camera to a place called livepixel.com, and they will do it professionally for you. But you can send in your camera, and what they will do is take the infrared blocking filter that's in front of your camera's sensor. They'll take that out and then put your camera back together. And they will recalibrate the camera so everything is normal. It's like you look through the viewfinder and everything's normal. The focusing on your camera is just like how it was before, and the shutter speed and aperture is totally normal. So you can take handheld infrared photographs, which is really cool. It's obviously the most superior method. It produces the best results, but it does cost a bit of money, about maybe, I don't know, 100 to 400 bucks depending on what camera you have. And another downside is that you can't really use your camera for color photography anymore if you go this route. Now, the second method is what most people do if the filter that's in front of their sensor is not blocking tons of IR light. This is what most people will do because they'll just buy a filter that you can put on front of your lens that eliminates visible light but only lets in infrared light. So not all cameras can do this, or maybe I should say not all cameras can do this well, because the infrared blocking filter that's in front of your camera sensor varies from camera to camera of how much infrared light is blocked. Now there are some downsides to this method. This method is pretty useful for landscape photography, but very difficult for portrait photography. You cannot see through that filter. Remember, it's blocking all visible light, but it's only letting in infrared light in. So when you screw that sucker on your camera, you can't see what you're doing. So you have to focus first, compose your photograph first, and then take a picture and guess and check and see if you got it right. So those are the two methods. Alright, by now you might be asking, alright, so I know that there's a filter in front of my sensor that blocks infrared light, but it only blocks it to a degree. So how can I find out how much infrared light it is blocking so I know whether I can do method 2 or not? Well, here's what you gotta do. Put your camera on a tripod, switch to manual mode, and then set the aperture to f10 and set the shutter speed to 1 second and ISO 200. Then grab a TV remote controller or something with an infrared light on it. Take a picture, and then during that 1 second, press a button on the remote controller while pointing it at the lens. Now, if it's very bright, that means your camera can take an infrared filter, and it's going to work, and it's going to work great. The shutter speeds will be around 1 second. However, if you can still see the little light, but it comes out kind of dim, that just means that your camera can still do it, but the shutter speed times are going to be much longer, usually about 30 seconds in pure daylight. Also remember to try different lenses, because some lenses transmit infrared light differently than others. Also try different cameras if you have them, of course, and different remote controllers. Some of them might not be working, or they might be sending out the infrared signal differently from another one you may have. Another thing you might want to try experimenting with is using the live view feature on your camera. This will give you instant results, and it's worth trying out. So try it all out, and if you can't get any results and you don't see that light at all, that means you should not waste your time buying an infrared filter. Alright, so if you're using method 2 and you have your filter, your infrared filter, the most popular one to get is called the Hoya R72. This is the filter that everyone uses, including myself. It's high quality, it's standard, it's pretty much the way to go. There are other ones as well, but they are much less common. So once you have your filter, how are we going to start taking pictures with this thing? Well, I'm going to walk you through it step by step. Usually I like to go to manual mode right away. I'm just most comfortable with that. And I'll usually use about maybe f11 on my lens and then adjust the shutter speed accordingly. And I always use the lowest ISO possible. And of course, when I'm taking landscape pictures, I usually have my camera on a tripod as well. So you're going to want to focus your scene using just the visible light. And then you're going to want to screw on the infrared filter afterwards, after you have it in focus. Then you're going to want to switch to manual focus, and then because infrared light focuses differently from visible light, some lenses actually have a little marking on the lens itself that tells you where to readjust the focusing point. So as you can see on this lens, it has a little red R. That means that I would want to just simply readjust the focusing point to where it was focused in normal color, and then just shift it to the red R, and then it would be readjusted for infrared light. However, a lot of lenses nowadays do not have the red R or any type of infrared focusing guide marker, so to say. So what you're going to have to do is just nudge the focus just a little bit away from the infinity point. And this is an experimental process. You're going to have to guess and check and preview the picture on the back of the LCD screen to see if it's all in focus and sharp. And you're probably going to have to do that maybe 3 or 4 times before you get it dead on tack sharp. Now when you take a picture, you might notice that the picture is completely red. And this is where a lot of people get confused. In order to fix this problem, you're going to need to reset the white balance. So what you're going to have to do is take a custom white balance picture with the filter on the camera and just point it at a patch of grass, then use that as your custom white balance picture. If you don't know how to take a custom white balance picture, you're going to have to read your instruction manual for your camera or look online, because it is different for every single camera out there. It's just slightly a different process. Now, if you've tried taking a preset white balance picture and it's not working, for some reason all the pictures you're taking are just coming out red on the back of your camera, what we're going to have to do is take our pictures in RAW mode and then reset the white balance on the computer. This is what about 90% of the people do. The only times when I don't do this is when I'm taking JPEGs with my Nikon D50, because my Nikon D50 can actually set the white balance correctly for JPEGs when I have my infrared filter on. My other cameras can't do this. So, let's go over how to reset the white balance for the RAW files on the computer. Alright, so here is a RAW file that I took with the infrared filter on. So I'm just going to drag this into Photoshop, open it up, and you'll see that the picture is totally red. And we can try moving the white balance slider all the way to the left and mess with the tint, but this still isn't giving us the look that we want to. The temperature still needs to go below 2000. So what we need to do is actually save this image as a DNG file. Now this is just a one-time process. So we're going to click Save Image down here in the bottom, and you'll get this window, and you just want to make sure that the format is on digital negative. Now save a copy of this on your desktop. Click Save, and now it's done saving, so I'm just going to click Cancel to get out of this. And you'll see that it made a DNG copy from the RAW file. So now what we're going to do is open this file up with the DNG Profile Editor. You can download this from the internet by typing in DNG Profile Editor, and then you click the first result and it will load, and then you will just scroll down until you get to this Downloads and Installation title, and you'll click the second one down that says Download DNG Profile Editor. So you download that, and it'll be this icon on your desktop. So we're going to double click that to open it up, and now you'll see that it brings up this window. Well, let's go to File, Open DNG Image, and we're going to go to the desktop where we saved it, and here it is. So now here's that file. What we're going to do is click the Color Matrices tab right here, and we're going to slide the temperature all the way down. Next, we are going to click File, Export Nikon D50 Profile. Now that's the name of my camera. If your camera has a different name, it'll probably say the name of your camera there. So just click that, and now it will automatically save the file in the correct place. Don't save it in a different directory. It should be in this directory right here that you see. Now I've already saved some presets right here, so I'm not going to save this. The one I saved before, it just says I just called it Nikon D50 IR. So I'm not going to save it, but if I did, I would just push the save button. So I'm going to click Cancel, get out of this. And now, when I open the RAW file again inside of Photoshop, you will see after you save that preset, you can then click on the Camera Calibration tab in Adobe Camera Raw, and right here where it says Name, click that and go all the way down to the file that you saved. Mine was Nikon D50R, and bam. Now what you can do is slide the temperature much more so it cools it down. And the best way of setting the white balance for any type of picture is to go up here and grab the white balance tool. Click that, and then you click on a spot on the grass, And that's usually what people do, and that's what I do all the time. So I like that, and now I'm going to click Open Image. So there it is. There is the infrared photograph with the correct white balance. Now, you're ahead of like a lot of people, because most people, what they do is they take that reddish looking image and then they get confused and they just make it black and white. You can get cool results from that, but this is even, I think the color infrared images are even better. So what I'm going to do now is just go to Image, Auto Contrast, and now what I'm going to do is I'm going to swap the colors. I'm going to make the sky blue and the foliage white. So to do that, what I'm going to do is go up to Image, Adjustments, Channel Mixer. Then this window will pop up. And you'll see that the output channel is on red. So what I'm going to do is make red 0 and blue 100. Now you'll see that I made the sky green and the vegetation pink. But to make the sky blue, what I'm going to do is go to my blue channel and make red 100% for the blue channel and blue 0%. So there you go. This is a very popular look that a lot of people use in infrared photography. Here's the before and the after. And of course you can mess around with them and make them different colors if you want to. Now what I'm going to do is make the vegetation white. You can see that it does have a red sort of hue on it. So what I'm going to do is go to my reds and just desaturate them completely.